Alright, it's time for the second round here. I think when I'm the here. I think when I'm the hacker rank ones first, no? I think I'm gonna put some music on the background, but mute it on stream so it doesn't mute the VODs later. And oh, actually, this one was the one that I saw the solution, which I forgot already. But I remember that he uses the product for from EtherTools, which has the combination of Cartesian. No, it's Cartesian something, I think, which does goes over all the combinations, the possible combinations of the calculations on tuples, I think. I don't remember really well. But let's try this one now. I think what I'm gonna try to do is do the Pomodoro, not Pomodoro technique, but similar to that, where I just go until I'm tired, and then once I'm tired, I start studying the other stuff that I have. It might be a great idea to open up the folder. Because usually off stream I can go for a lot longer periods, especially doing these challenges. But what I usually do off stream is I studied, then whenever I get tired, I take a break and then I go back and forth. And when I'm streaming is a little bit different, so. And that's why I have to take pauses after every 2 hours, but maybe I can go for longer if I just do these intervals like this, where every time I get tired, I just do something else or don't do anything at all. Just wait until I can focus again. Because after around 2 hours, it's kind of like my brain shuts down. I can't really think about the solutions anymore. It's kind of weird. So it might be a good combination to go through the problems and then maybe look at the source code or investigate the solutions once I get tired again. I think that's what I'm gonna do. Okay, so valid postal code P have to fill both below requirements. P must be a number in the range of from 100,000, I think. Yeah, 100,000 to a million inclusive. P must not contain more than one alternating repetitive digit pair. Does not contain more than one alternating repetitive digit pair. So I think what I mean is that you can have, for example, 2, 1, and 2. More than once. Alternating repetitive digits are digits which repeat immediately after the next digit, okay? In other words, an alternating repetitive digit pair is formed by 2 equal digits that have just a single digit between them. So it's just like I was saying. Here, 1 is an alternating repetitive digit. Here, no digit is an alternating. Both 2 and 5 are alternating repetitive digits. Because they are separated by... Okay. So this can't happen twice. And it must be from this range here. Your task is to provide 2 regular expressions, regex integer in range and regex alternating repetitive digit pair, where regex integer range should match only integers range from 100,000 to 1 million inclusive. Huh. I hate regex actually, to be honest. But obviously, if we're thinking about the numbers, then it's pretty easy to do this. But I'm not sure if how to do it on regex. I know for to getting numbers is D, caps lock D and normal D gives digits from 0 to 9. So probably doing that with the asterisk later. And I guess this is the test where the input's gonna be the thing, and it's gonna try to match these two regex here. So it's a regex test. So not obviously, but there's probably a trick here. Since it's supposed to be one of the hard challenges. But I think for digits this should be something like this. I actually suck at regex, so I hate it. Only integers. Okay. Or should it find the alternating repetitive digits pairs in a given string? Both these regular expressions will be used by the provided code template. Check if the input string P is a valid postal code using the following expressions. Locked stub code in the editor reads a single string denoting P from standard uses provided expression in your regular expression to validate if P is a valid postal code. Output format, you are not responsible for printing anything to standard out. Locked stub code in the editor does not. Show alternate digit pair since it's an invalid postal code. Note a score of 0 will be awarded for using if conditions in your code. You have to pass all the test cases to get a positive score. This one is the harder one. Because how I'm gonna check? I think there's a special thing to put any character, just say any character. That's how I'm gonna say the same digits. That's the thing. I actually think I'm gonna look at the solution of this one and move on to the next one because it's just regex. Usually, whenever I encounter regex, I just look it up the solution. Someone has already implemented some solution to whatever problem it is. So basically, it's probably just like this. I just slash the zero 103 123 123. I think that's the first one, probably. D099. It seems to be, unless this explanation doesn't work. The issue is the other one. Maybe I can test to see if this passes at least some tests. The problem with Hackerrank is that I can't test. I can just do the simple tests first, and the other ones I can see because they are locked. Because they're repeating. So maybe I should just look it up as well. Yeah, the issue is that I have to figure out for. So maybe I should search for how to represent any input. Or I guess I can just do a number in between them. Like this. Hmm. Oh, it's this one, the question mark, I think. I also think it's not gonna work, but um, let me see if I just take this off. It's probably not gonna work. Then I'm gonna try the other one. It's probably not gonna work anyway. I wonder if there's a good way to become good at regex. It's not something I come across at all, actually. I'm trying to build things. At least the things I tried to build so far. Maybe it's used somehow. It's probably used. Uh, if they're testing for it, it's probably used, but think parentheses is for groups. So maybe we should do two parentheses and then in between them the question mark. The thing is, it's gonna return a match for the digits, but I don't know how to capture the same digits. I don't know if it's gonna capture the digits specifically and then in order to compare with the other one. That's the problem. I guess I can use this to but it's still because if I use this it's gonna give me one and it has to be greater than one occurrence. And I also have to think about how to capture the any character in the middle of the two repeating ones. I think I need to create something like a group inside of this, and then I should put this here, something like this, and then here put something to indicate that there's something in between them, but also don't think that's gonna work. That's the problem. Maybe we can use the question mark once or 0 times. I don't know. We just run this, probably not gonna work, just to see. Oh, it worked. Nice. It's probably the other one's gonna fail. I hate regex, just so annoying. Oh, it actually passes several of them. I wasn't expecting that. I think the first one is good, but this one I probably should put something in the middle here. Maybe the plus sign. Uh, Cause how I'm gonna capture the digit, the exact digit, not any digit. Because if I put a D here, it also doesn't make sense. I think that's the main point of confusion for me, is that I don't know if it's gonna remember the character that's the specific digit that is matching or not. Because they're all digits, so. Or maybe if I do. But if I do a group there. Like if I do it, it's probably not gonna work anyway. I'm gonna read a couple, I think 2 more blogs or articles, and then I'm gonna look at the solution and move on to the next one. Maybe I can use these ones. Hopefully in the explanation of the solution they talk about this thing that I'm confused by. Let me see if I remove this. And the problem is that I'm getting in the beginning and in the end. It's not the exact pattern that they are asking for. Maybe how can I say it 3 times? Maybe if I separate them into different groups and then I do one in the middle, like this, and then I put this salting inside of a group as well. I think I'm passing one more. Probably don't remember now if I was passing 3. I think I was passing 4 already. So probably didn't change anything. I think I'll be right back. I think I'm just gonna look at the solution, to be honest, for this one. I also think I'm gonna go faster through them. It's probably better instead of just uh, spending so much time on each one, because I think I probably get more tired whenever I do this, where you just keep thinking about the same thing. It's probably better to increase the volume and go faster. That way I'm gonna have more repetition of the methods and seeing a bunch of different solutions. Or maybe I should do a mix of both of them. Or sometimes I try really hard on a specific problem that I can't solve, and other times I'm just trying to do a bunch of them without really uh, spending a bunch of time just thinking about a way to solve it. Maybe I should do a Kaggle competition as well. It's gonna help me a lot on the tests, on the Turing tests. And it forced me to use the methods that are used the most to clean the data and make machine learning analysis. I think I'm just gonna look. So I think this matches at the date. And we can try to use this one, the way that is written here, to capture the pattern that I want. Hmm. This one looks interesting because it's repeated here. So if I catch this part, it's probably what the challenge wants. I'm not sure if I understand this. Oh, it's probably digits then 4. So maybe I can try to do it like this and use 1 instead of 4. But it still doesn't solve the problem of getting the same one. That's the thing. Or maybe if I use these symbols, special symbols, like this, 1, 1, 1. And then I do here. Oh, actually, like this. Yeah, same thing. So I think I'm just gonna look. Hmm. Yeah, I think that's for the second one, and this is for the between 100 and 100,999 thousand. And this is the one for the checks for the repeating ones. I think this whole thing probably. And I still don't understand it. First parenthesis delimited expression inside of the regex. It will return the number of alternate matching pattern, which should be at max 1. So the condition is of greater than 2. So that's why greater than 2 here. Read.findAll function will take a pattern and a string. So it matches. So we matches the digit matches if matches next, but doesn't consume any of the string. This is called the look ahead assertion. Interesting. So this matches a number only if it's followed by a repeated. Yeah, but where is the number in the middle? That's what I don't understand. Yeah, but this doesn't work now. Because I think they're only taking regex solutions. So this is a positive look ahead. Positive look ahead, see if there's a match without actually matching them. So that they can be used to find additional matches instead of being registered as already being checked. The period matches anything that follows the first digit. From back to the original capturing group. Okay. So this is kind of like pasting the D here. So basically match a digit and check to see if there's anything next, followed by the same original digit. Yeah, I like this explanation here. Makes a lot of sense. So this is the stuff used to check for any character after a specific pattern you're trying to capture. And the dot captures any type of character, I think. The look ahead is for checking to see if there's something after the this. And then the number one is for how many times the original one's gonna repeat, I think. Nice. Okay, so I think I'll check the other one. So this one, this one. After that, I'm probably gonna continue with the Code Wars once. And then depending on how tired I get, I'm gonna study this stuff here again. Maybe I should do the data engineering, since I already looked at all these topics here. But I also think I'm gonna look at the source code of these methods here. Maybe do a Kaggle competition as well. Neo has a complex matrix script. The matrix script is NM's grid of strings. It consists of alphanumeric characters, spaces, and symbols. To decode the script, Neo needs to read each column and select only the alphanumeric characters and connect them. Neo reads the column from top to bottom and starts reading from the leftmost column. So it starts from top to bottom and from the left. So like this. This is matrix. If there are symbols or spaces between two alphanumeric characters of the decoded script, then you replace them with a single space for better readability. Neo feels that there is no need to use if conditions for decoding. Alphanumeric characters consist of this. No, so I'm probably gonna have to use regex again. Input format, the first line contains space separated integers and so rows and columns respectively. So n is the column, n is the row, m is the columns. And then I think this is the input, the text. I'm not sure though. A 0 score will be awarded for using if conditions in your code. Print the decoded matrix script. So I think this is the each line of this. And this is pretty hard. So for this in range n, matrix dot item input equals input, matrix item equals input, matrix dot append matrix item. Trying to see if I understand what are the letters here. So n and m is gonna be what determines the size of the matrix, but I don't understand this part here. It's putting into this matrix, but then what is this one? Now first multiple input. So I guess this is just to decide the size of the matrix here. I don't get this part though. I guess this is, but this is just the matrix. And then I should use n and m to read the matrix there. And I can't use if statements as well. Alright, I think I understand now. I'm also not sure. I shouldn't use other libraries probably outside of these ones. Not sure why it's importing random here as well. So what I think I should do is reshape this matrix here based on these two inputs. And then, yeah. Well, actually, so n is the rows. So this is creating the rows here. Because it's in range n. I don't understand. Because it would make a lot more sense if this was the m and not the n. Well, actually, no, because yeah, n is the rows and m is the columns. So I have to divide this matrix based on m, I think. Because m is going to determine the size of the lines. And here is just the inputs in a list. The rows of the inputs. So the rows divided by the columns is gonna give me the matrix. I'm trying to think what is the final, what are the sequence of steps that I can do to transform this into a line that goes from top to bottom and then left to right. And n is gonna be the rows with the input, but that's the thing, I'm not sure how the input is being done. And that doesn't make sense. I guess it's one by one, but because this matrix can be either from this 7 until here, or from this 7 until here. So it can go up, down, and then up, down, or it can be just up, down. That's the problem that I don't get with this. The first line contains space-separated integers and n rows and m columns respectively. The first line. Next n lines contains the row elements of the matrix script. So I guess the size is gonna depend. This matrix is just gonna be up, down, and the size of the thing is gonna depend on how many times I divide this by m. But if I wanna go up, down, then up, down, how do I do that? Yeah, just divide by m. The only issue is what if it's an odd number, or if it breaks down. How I'm gonna do that? So I think I'm gonna write things down here. So if I divide this matrix by m, I'm gonna have the blocks in the lines that I wanna parse. The rest I can just use the regex. I can just loop through the new list after parsing this one and replacing the characters with the regex. So what's the problem with this is if I get a number that is not divisible, so if n is 13 and m is 7, for example, then it's gonna break down, so I can divide. So I have to use the remainder. This- Uh, how to discard the remainder division in Python. But I think what I have to do is divide the length of the list. So let me write below this length of list of matrix by m. Make a list with the round part of the division. Make another list with the remainder. So I have the two lists based on the... Yeah, but that's the thing. As for every round number, I need to... I'm not sure if I'm getting this correctly. I think that's it. I think this step is just to go from the list to the matrix to get into this form, but it's not the final string that I want. That's the thing. Because if I do these steps here, I'm gonna go from the matrix to this input here, I think. Yeah, I can create a nested list based on that, and the nested list is gonna be emulating this matrix here, and then I can see if I can get a method to get the first character of each number. Yeah. So then add the two lists. Oh, but then, yeah. Because I want to make a nested list. Divide length of matrix by m. Oh, maybe I can append to another list based on the... create another list, a nested list from subsections of n, of m size. That's gonna give me the matrix, and then I can get the first char of each list inside the nested list, and put and append to another list. Do this until length of sublist. Not sure if that's making sense, but... So I'm gonna have a nested list, and then I'm gonna loop through the list inside of that list, putting the first character of each one inside of another list, and then so on, until I have a list of the sequence. The final list is gonna be the sequence of all the characters. And then loop through final list, make regex, or I can either loop through the final list and making the regex thing, or I can just join the list first and then do the regex pattern. We'll focus on the first things first. So I guess I can use in range to make the steps. Yeah, from 0 to n. So I'm gonna make another list here. Yeah, but then how do I say? Because that's the thing. I can't append just elements. I need to create a list of the thing. Your bread back. think I'm gonna search for how to make a nested list. Hmm. Nice. This is exactly what I want. So I think I can do this. And here's gonna be but then it's not I plus 3. So I plus m. So probably this should give me the nested list that contains there's gonna be equal to this matrix here. Now I have to think about how I'm gonna get the first character of each one. How I'm gonna access the line based on that. Each list is gonna be a row inside of this list here. Maybe I can do for I in range length final matrix. I think I can access. Actually, I can't do it like this. I think I have to do it for item in range. No, for item in final matrix. Maybe we can use enumerate. Because I have to loop for in all of them in the outside, and then I have to capture the each element of each one. Think, trying to think if there's any way that is better than doing a nested loop. I should just look it up. can I do this? Maybe I'm overcomplicating things. Because the problem is I'm not sure what the matrix is here. It can't be, there can't be the rows, the logic of the columns here, because this is just looping through the rows. But I'm not sure what this input's gonna be. That's the issue. Because if the input is contains the size of the column, I don't think that makes sense, because otherwise they wouldn't put them here. So I think input has to be one letter at a time. But then also doesn't make sense. That's the thing. First line contains space separated integers and them rows, columns respectively. The next n lines contains the row elements of the matrix script. So I guess the matrix is the list containing the rows. So to get them in the matrix form, I have to do this. And is there any way to... maybe I can already... Because I think I can skip this step here if I do it... If I don't create the nested list, if I just append each element to a new list based on the range there. But that doesn't work because I don't want to get them like that. Because I would have to keep track of each line, each iteration, to get the first element of each iteration. It's better to put them on the matrix first and then think about how to translate the columns, the rows and the columns into one line. So I have a nested list of rows, and I need to think about a way to convert that top to bottom. Maybe there is some of those algorithms, depth first search or something like that. Should do that. Well, the thing is, I can't use if statements as well. It's actually pretty hard. It seems so simple. That's because all I have to do is put them together, but and I know I can access them by doing this. For example, so I think the first is on the outside and the second is the list inside. And so the first is the rows, the row, and then elements inside row. And I want to loop through this one, through all of the rows, getting the elements of each one. The elements have to stay the same, but the row has to change. So maybe the only way is a nested for loop. I can do for I in range, then lay. And the problem is that it's actually really confusing. Is there a better way to do this? Trying to think if there's a way to incorporate a dictionary somehow. Or trying to make sense of the nested loop to structure in a way that I can transform everything into a single line. Problem is if I do key and enumerate there, it's not gonna, it's gonna increase the key for each element. That's not what I want. That's the issue. I need to figure out how to maintain this fixed for each iteration. But the only way to do that's with a nested for loop, I think. And that's the problem because then I'm gonna have to loop a bunch of times through this. But maybe it's the only way. And the issue is that I don't even know if this is working. That's the problem because I have to do all this stuff just to see if it's gonna work or not. So after I do this and I append this to another list and parse it, make it into a line, then I will have to loop again through the other list to do the regex stuff. I think that's the easier part, I think, probably. The only issue is using all these loops to try to do this. Maybe I should do what I said before and just try to do it in the easiest way I can think about, and then I think about the other stuff. Because I'm not even sure if that's gonna work. But the thing is, I shouldn't be equal to the length of final matrix. It should be equal to the length of all the elements, I think. Or to the length of item, that's the thing. It has to be equal to the length of each row. No, because I think the rows are always, yeah, maybe they are not gonna be the same length actually. That's the problem. Yeah, what if they are not the same length? There must be an easier way before this step here. Not sure if this is the best way. Because maybe if I change this matrix here, in some way it's gonna be easier to get the lines of each one. And then I don't need to do this nested for loop here. The length of the matrix should be the length of the rows. Let me think more about this. I think I'm gonna write here this example here the way that I'm imagining what the matrix is gonna be. Yeah, but then that's the thing. It's gonna be I wonder if I can split before here as well. Before appending to the matrix. Because if each input is this line here, then I could just split the input and then do the line based on the size of M and append to the list as a sequence, as the final sequence. They also import math here, so there might be some function to help. Oh, so the first two are the size. That's why it's 7-3 here. Mm. The row elements of the matrix script. I think I can change this part here before it appends to this one. I'm still having trouble thinking about a way to append in the correct way. Because the issue is it goes row by row, so unless I make, yeah, but even if I make a bunch of lists, I can think about a way to create lists dynamically. Let's see here. Yes. Matrix. So maybe I can create a tuple or something like that. I can split the... And the thing is, not all of them are gonna have all the characters. I can create a tuple with each one of the variables here. But then the problem is I'm not gonna know how many columns exist. So I can't put a fixed size for the tuple. So each element is gonna be... I think I'm thinking this the wrong way. Because each element is gonna be this thing here. So what I need to do is loop through the n and then split the elements. And I think I want to do a nested list. I think I'm overcomplicating things probably. I just loop through the matrix and then each item is gonna be a row. And then, yeah, but then that's the problem because if I create 3 different lists, it doesn't make sense because it has to be equivalent to the number of columns of each one. I think matrix is gonna be like this. I'll write it down so it's easier to think about it. So based on M, I need to get the characters of each one. Yeah, but that's the thing, because how I'm gonna get them into a line? Based on the M size. So first I have to loop through this, then this, the first one, then the second one, M amount of times. So the first thing I have to do is loop through the thing, but I think I'm gonna erase this. So now I have to think about a way that I can keep track. I have to loop M amount of times, but only get the first character first and then the second and third so far. To put them on a string. I think I'll be right back. I'll go to the bathroom. What I'm thinking about is obviously doing the range here, but it doesn't work. I'm probably missing something. For I in range. But the issue with this is that he's gonna go sequentially and not. I need to capture each one for each iteration. M times. That's the problem. Maybe we can create a dictionary of lists and then use the dictionary to get the words, I think. But then I have to think about how to do that with Python. What I'm thinking is creating a dictionary, and then the dictionary has m amount of keys. And then through this nested loop here, I put each word on the specific key of the dictionary. Or maybe I can make this string already as part of the key. That's a good idea. But then it would be the other way around. Okay. String for K in range M. So that way I created it. Oh, but that's at least of dictionaries. And that's not what I want. I can just do this loop here. X equals this, and for I in range M, xi equals empty string. This should work, I think. So this is going to create a dictionary where each number from 0 to M is equal to an empty string. And now I can add the words into this dictionary. Or I can make this right away here. Alright, if I do this I equals item I. Oh, but item. Maybe this works. And then I don't need this first part here. Or maybe I have to put plus equals, actually. Because the idea is to have the dictionary use the dictionary to separate each word into its respective line. And then once I have the final dictionary that is going to contain M keys, each one is going to be a line. Then I can just loop through this dictionary and sum all keys into one line. And then I can do the regex stuff to parse the final string. I'm not sure if this works. So let's think. Let's say the first is gonna be this one. For I in range M. This is gonna be the first key of the dictionary is equals plus equals item I. And I think it works. So let me assume that it does. And then I think I can do final equals this for dix dots for and then at the end I parse with the regex. But I can use if statements, that's the problem. So let's think about this. So here I'm putting all the values inside of this final string here. So here I need to replace the regex pattern. To decide the script new needs to read each column and select only the alphanumeric characters and connect them. New reads the column from top to bottom and starts reading from the leftmost column. If there are symbols or spaces between two alphanumeric characters of the decoded script, then you replace them with a single space. That's the issue there. So text before is going to be final. And how can I say anything that is not this? There's no alphanumeric characters consists of and this. So I think this is gonna be this. And the replacement has to be this. I think I don't remember really well, but maybe I need to put it like this. I don't know. My hash should be inside string. I think I'm gonna search for what exactly what they are asking here. Read each column, select only the alphanumeric characters and connect them. Also, you can use a filter. I want to remove all known alphanumeric characters from string. Like them. Yeah, but I can use the if statements, that's the problem. Maybe this one is gonna work. There are symbols or spaces between two alphanumeric characters of the decoded script. Symbols are spaces between two alphanumeric characters. Replace them with a single space for better readability. Also, anything that isn't this, I need to replace with a space. I think I'm gonna comment this one. Try this one in case this one doesn't work. Oh, but this one is using an if statement. Can't use that. So maybe this one is better. This approach is better. There we go. Let's see. I think I should just run it and see what kind of problems I'm gonna have. Oh, nice. It's better than, than I thought, to be honest. Yeah, so I don't understand why they're saying that I'm only supposed to have this. But then on the output there you have special characters. And select only the alphanumeric characters and connect them. Reads the column from top to bottom. There are symbols or spaces between two alphanumeric characters of the decoded script. Then you replaces them with a single space for better readability. So I guess it's just whenever there are symbols. Let me output final to see what a final is. Okay, nice. At least I'm getting this string. I was just figuring out how to get the regex right. I'm already pretty happy with this, to be honest. It was really difficult. Or maybe I overthought a bit as well. So I need to replace. Yeah, but how am I gonna do that without? Or maybe if I change the regex here. Yeah, that's probably the key. And is this one the one that I'm using? I don't think it is. Yeah, there's two issues. One is that I'm replacing the space. So maybe I should put. Yeah, how am I gonna say to not consider spaces? I think I can remove the spaces after. The only issue is this end of the line here. And yeah, this here. I think I can use the look ahead, I think. Ah, that sounds interesting. I can do the thing here of the previous question. And then I probably should put this inside of a group. Let's run it, see what happens. No, it's not replacing anything. But I think I have to use this look ahead thing. And if I remove this. Because the first part catches non-alphanumeric. This part here. Maybe I should use the look ahead before. I should use this. Here. Here. Yes, I guess this W also matches from A to B or something like that. I think I'm very close to getting it right. But yeah, the issue is the final ones. Maybe we should search look ahead in Python. Maybe if I do yeah, like this. I think I need to use it's the same logic from the previous one. I just need to figure out how to put it here. And I probably should use this escape and one here. I don't remember really well. Maybe I should go back to the other one and see how it works. I think that's what I'm gonna do actually. And then I can use that one and try to uh, change the only change instead of digits to use any alpha non-alpha no alphanumeric characters. I think that's what I'm gonna do. It's probably better than looking it up. I just have to find it here. I think it was this one. And regex is such a bitch. I hate it. I think it's this one, the one that I remember. Oh yeah, the dot thing. I forgot. The issue is that it's gonna match anything. But maybe I can adapt this to do what I want. So I think instead of the dot, I need to put the non-alphanumeric stuff. I should probably remove the plus sign as well. Alright. I think the mistake I was doing is that he did it in groups here with the slash one. Hopefully this works. Let's see. I'm still doesn't work. I'm so close that I don't want to look at the solution because I think, yeah, just figuring out this stuff and then it's gonna work. Maybe if I do the plus, or I can try with the dots as well. Hmm. What if I take this off? At least I'm getting something different here. Interesting. So this is replacing the one before. So what if I just remove this look ahead stuff? I think I tried this before and didn't work. Yeah, that's the issue. I think I have to start from this one because this is the same pattern. The slash D captures any digit. The question mark equal is a positive look ahead. Positive look ahead, see if there is a match without actually matching them. So that they can be used to find additional matches instead of being registered as already being checked. Matches anything that follows the first digit. Yeah, so it should be once the reference back to the original capturing group slash D. It should be this one. That's the thing. The only difference is instead of the D, I need to put. But I don't understand why it doesn't work there. Because here should be alphanumeric, and then here should be non-alphanumeric. Instead of the dot, because the dot's gonna capture anything. On this, I think I tried already. Doesn't work. Let's see if I do this. Ah, Or maybe I need to use the plus sign. So what if I do... Actually, it's better to copy this one. And plus here. Remove the dash. Don't understand why it doesn't work. I think it's because of the dot, but then if I replace it doesn't matter anyway. Captures any digits, pause to look ahead. Maybe you should watch a video on this pause to look ahead to understand better how it works. Here's a match without actually matching them so that they can be used to find additional matches instead of being registered as already being checked. Your period matches anything that follows the first digit. Here's a reference back to the original capturing group. So basically match a digit, then check to see if there's anything next, followed by the same original digit. So why doesn't it work when I replace with the other stuff? But then here should be anything that is not. But I don't think that's gonna work. Yeah. It's exactly what I'm using here. Oh, it's inside of the thing. Maybe that's the problem? No. Maybe if I take this plus here. Yeah, this one. Let's try it out. And this one removes the is the exact opposite of what I want. And it's only removing one. That's the issue. And this is the same. Hmm. Maybe if I just put this stuff on the beginning there. That doesn't work. Right back. I think I'll try a couple more. And then if I can't figure out, then I'm just gonna look at the solution because I think that's the only thing that I need to do left is to figure out the regex. But the rest I think it's fine and I'm pretty happy with that already. So beginning and end are like this. So maybe what I should do. Where is it? But this is gonna remove all of them. It's not what I want. I'm thinking about just writing the pattern where I put this in the middle and then the other ones. Yeah, it doesn't work. So I can try to do this. Oh, actually, this doesn't have numbers as well. Oh, is the numbers? Never mind. So I think I can do this. The beginning. beginning indents. It doesn't work. So I think I'm gonna have to look it up because I don't know what else to do here. If I take this off, let's see. Yeah, it doesn't work. It's probably not gonna work as well. Hmm. If I could use if statements, obviously I would do a loop and then check for the patterns and replace. Maybe if I search for this is a better way to search. That's the thing. Do you want to watch a video about this? Hmm. That doesn't work.
Hey guys, welcome to the 16th video of my series on regular expressions in Python. And in this video, we're going to talk about a bit more advanced topic, which is called look ahead. So before we talk about look ahead or anything else, let us take a look at a very simple example. So let me import the regex module, and now let me specify some text, which is red, green, blue. So now consider that you want to search for green in this particular text. You want to search for the green word actually. So as we have seen in the boundary matches that there is a word boundary meta character which is /b, which you can use if you want to look for word boundaries. So I just wrap my green with some word boundaries before and after writing green, and now it will match only for the word green. So if I just try to find, I get the output. Now one thing to notice here is that /b is actually not a part of your output. Isn't that interesting? That /b is not a part of your output. So what is /b actually doing here? /b is actually checking if green has some kind of word boundary before it and a word boundary after it, but it is not actually a part of your output. So what is it?
Interesting. So maybe I can use this one there. Just to /b here, /b here. Mm. Doesn't work as well.
So what is it called? What is this behavior called? This particular thing is actually called zero width assertion. Zero width assertion. So the characters which indicate positions rather than the actual content are called zero width assertions. So basically this /b matched with this space, but this space will not become the part of your result because it is not actually matched with the pattern. So it is just a kind of a check that you are making here, a kind of an assertion. So this assertion, since it is not taking any space in your output, it is called zero width assertion. So just like this, just like /b, there is the caret symbol to check if there is a start of line, or $sign to check if it is end of line. So all those things, all these boundary matches are actually zero width assertions. So the property of zero width assertion is that they do assertion without consuming any kind of characters. They just return a positive or negative result of the match. That's it. So this is the concept of zero width assertions, and a more powerful kind of zero width assertion is look around. So now look around is a new term for you, which is a new mechanism that you can understand. So it is a mechanism with which it is possible to match a certain with which it is possible to match a certain.
What I don't understand is why when I put this here, it doesn't work. Should give me... Oh, so it does work. What if I put this here? Interesting. And the problem is that's gonna take this one off as well. That's the issue. Because if I do... I think it's the start to take multiple of them. Hmm. This one almost works, but not quite. What am I missing here? If I put this here, it's probably not gonna work.
pattern before or after your current position. So basically right now you are just checking if there is /v, a kind of a word boundary before green. Then by using look around, it will be possible for you to check if there is a particular regular expression before green, or there is a particular regular expression after green. So if this is possible to do by using the mechanism of look around, by using look around you'll be able to check if before green there is a particular regular expression, or after green there is a particular regular expression. But again, that regular expression will not be a part of your final result. That will be a 0-bit assertion. So I hope the concept of look around is a bit clear. So now, just to increase your understanding, you need to understand that the look around actually consists of two parts. The look around mechanism that we are talking about, the patterns which use the look around mechanism have two parts: the actual expression and the non-consuming expression. So actual expression, just like green here, is an actual expression which constitutes the part of your result. And then there is non-consuming expression. The non-consuming expression is an expression whose match is evaluated before the actual expression, just to see if it can succeed. So basically, you just check this particular expression before actually matching green to see if it can succeed, or you check this before actually matching green to see if it can succeed. Only if it succeeds, you will match for green. So this is the concept of look around. So on the basis of some kind of differences, we have some categories of look around. There is look ahead, there is look behind. So in look ahead, you check if a particular regular expression succeeds after your actual expression, whereas in look behind you check a particular regular expression is succeeding before your actual expression. So these are the two differences. And then again, look ahead has two types: positive, negative. Look behind also has positive, negative. So in this video we are going to talk about look ahead only. We are not going to talk about look behind. Look behind is going to be a part for the next video. So let us talk about look ahead again. So what is look ahead? Look ahead is a mechanism which checks the match for a non-consuming expression ahead of a given pattern. So basically, if you have an actual expression A, then you might want to check if there exists a non-consuming expression B ahead of your actual pattern. Okay. So if you want to check this kind of thing, then you will say that you are checking look ahead. And if you are checking if B succeeds, then we call that positive look ahead. And if we want to check if B should not succeed, then we call that negative look ahead. So these are two categories. So let us take a look at the definition. Positive look ahead will succeed if the past non-consuming expression does match against the forthcoming input. Okay. So in the case of positive look ahead, we try to check if your non-consuming expression is matching with the input. Whereas in negative look ahead, we want
If I do this followed by positive look ahead, let's
it to not match. So the syntax actually is you write your actual pattern in the normal way, then you create a parenthesis in which you put question mark and equal to sign, and then you write the expression, the non-consuming expression, which needs to be checked before actually checking your actual expression. Okay.
so I can do this and then this. Yeah, I think I'm gonna have to look.
So let us try to see. Let us try to understand it with an example. So let's say you want to find a match for love in this particular text, but you want to find a match for love only if it is followed by regex. Okay, that is what you want to check. So let's say you do not know about look ahead or look around, anything like that. So what you can do is that you can simply search for the complete pattern love regex. If you do that, you will get your match. Match will span from 17 to 27, which means from this index to this index. So actually the result is this complete thing. Look ahead, positive look ahead here. So how do you apply the concept of positive look ahead? You just write an expression like this: love should be followed by regex. So we do that. We put parentheses. So let me write that again for you. So love is there. It should be followed by what? Space and then regex. So since it is a look ahead, I put question mark equal to sign. Then I put space and then I put.
So it is this and then this. Maybe I should put here. This should be followed by this. Oh, and this should be inside of the thing. And the issue is that it's probably the other way around. Because I'm replacing the one that comes before and not after. And I also have to replace all of them. That's the issue. if I put the dollar sign, probably not gonna work. Because it has to be in between, that's the other thing. I think I'm just gonna look it up. I'm gonna finish this video and then look it up.
regex. That's it. This is all you need to search. So now if I just try to check the span of my match, it is 17 to 21. 17 to 21 is only this much part love. Or let me highlight it for you. So look at that. So this is the exact thing that I need. The exact thing that I needed. I wanted to find a match for love, and that match should only follow with should be followed by regex, and that is what is happening here. So I hope the concept of positive look ahead is quite clear now. But still, let us take one more example. So let's say I want to find all the words in my text which are followed by comma or full stop. So how do I do that? So I will write a pattern for it. Pattern is re.compile, in which first of all, what do I need? I need to find all the words, right? So /w plus. So this is what I need, but there is a condition that it should be followed by something. So that followed by something thing should be checked before I actually start matching my word. So for that I can just put a question mark equal to, and now what should match? It should either be a comma, or it can also be a dot. So I just escape that dot like this. So this is what we need. So let me just check pattern dot find all. So look at that, we get red, green, blue, because red is followed by comma, green is followed by comma, blue is followed by dot. So let me just highlight the result for you. So look at that, we are getting the desired result, right? So in this way, we have used the concept of positive look ahead. And so basically the benefit that we are getting is, first of all, it is an efficient solution, because before actually checking this complete red thing or green thing, we are checking if we have a comma after it or not. If there is a comma, only then I'm going to start matching this thing, right? So that is an efficiency that we are gaining here. So yeah, so this is what positive look ahead is all about. Let us take an example of a negative look ahead to end our video. So negative look ahead, which simply means that, let us understand the example, okay?
Maybe it's to search for the in-between stuff that I talked about. Look around. I think I'm gonna try this one last try, and then if I can't do it, I'm gonna look at the solution.
Welcome to this regular expression tutorial, and we have in the last episode matches any kind of email address. But now we have some unique thing which is called look around, or we have two different kind of things like look ahead and look behind. And in each of these, that means in look ahead we have two, look behind we have two, positive and negative. So let's learn about this. And for that, now I will go to this website, because now this we are going to play with groups, and now we are going to see the result directly here on the right side. So suppose I have a website which is like google.com, then another website of Google which is not secured, so it doesn't have S here. So this is very good, but now what I'm going to do, I'm going to firstly match it. So how we can match? Yes, I need to say first HTTPS, then we need to escape it, so like this. And let's do one thing. These things we just want to match it when you are matching on the first group. So let's remove the second group. On the first group, at the starting of the parenthesis, you need to say question mark, then less than sign, and then equal to. So it's just going to say, okay, match everything we have here. So it says that don't include everything inside the result. So we are matching it, but in the result we are not getting it. So we have some kind of error. So pattern error it's saying, which is because of this question mark. So question mark is creating the problem. So if I remove that question mark, you can see the full match is actually www.google.com, and this is not working on the second case. Why is that? So actually what we can say, we can move this inside character set, and now it's matching, and eventually it's working fine. So yes, we have done that. So this is actually the look behind, or we can precisely say it is positive look behind. Positive means match everything you have here. But again, we have some different kind of pattern that, like say I have a price is $400, then again I will say price is not dollar, price is euro 400. Then I just want to save the numeric value, whatever it is, from whatever is the currency. So I just want to remove currency and the number. So let's do the same thing with look around. So now I will say I need a digit. So digit matches more than one matches, but doing this is just going to match everything. So this is also matches. This is not any kind of price. So it just matches that, but I don't want. So here I can say I want to match dollar. That's okay. So it matches first one, or euro. So euro is also matches. But you know, in the match we are getting that euro and dollar. So yes, you can move this inside brackets. Yeah, we are getting the second. We are getting the first group as this. But as in the previous example, I want full match to be 400, not the dollar. So I can move this inside the parenthesis, and I will say question mark, less than sign, equal to, and yes, we want only the number, so we are getting only the number, nothing else. So now after that, let's talk about the negative look behind. So negative look behind is just opposite. We just want to remove anything which has this one and get all other things. So like if I say for the look behind, we just need to say this X or the dollar sign and having .ru in the end. So yes, we can include that. So I just say A to Z, one or more, then .ru. So this is good. So .ru is selected, but I think let's change this one also to .ru. Okay, so we have selected that. equal sign, negative look ahead. For that, you just need to use exclamation mark. So question mark will say, okay, it's not going to include it in the result, but the exclamation sign says, okay, even I don't want to match this thing. So after doing this, we have some weird thing. You can see this actually.
All right, what's going on, guys? All right, so welcome to Python regular expressions made easy, part 14/2 or part 15/2. So this is part 2 of lookarounds. In the last video, we were introduced to lookarounds, and this video is just a continuation of the last video because the last video was pretty long. Okay, so let's get started. Now, this is a very important topic. So consecutive lookaround fallacy. It should be. Okay, all right, so consecutive lookaround fallacy. Okay, so what I mean by that is, I'll give you a clear example. All right, so we have the string, it's a multi-line string, cherry 100 red, apple 150 green, grapes 250, nothing here. So our pattern, what it's doing is we want to look for, make sure there's a number and make sure there is a color. So essentially we want to make sure there's a number and make sure there's a color, and we want to pull out any fruit that satisfies the condition. So if there's a number and a color associated with the fruit, we want to pull out that fruit. Now, I'm going to run this and run this, and now we get an empty string. And I want to show you guys exactly why. There's nothing wrong inherently wrong with the pattern, but I want to show you one of the key misconceptions or the key mistakes people make regarding lookarounds. So the thing you want to be careful of is that having two lookarounds doesn't mean it's going to look for one followed by the other. So in this case, we have this lookaround followed by this, followed by this. Okay. So this entire thing doesn't mean we're looking for a bunch of numbers followed by a bunch of space followed by more numbers. That's the thing we need to really be careful of. So let's just break down this pattern and really look into what I'm talking about. So we're looking for a bunch of letters between A to Z. So we have a bunch of letters between A to Z. Okay, this gets captured. Then we're looking for a space, as many 0 or more spaces. So this entire thing gets captured. Now here we have a lookaround, positive look ahead, and we're looking for a bunch of numbers. So we're looking for a bunch of numbers. Now what happens is this actually doesn't get consumed. It actually just looks for a bunch of numbers, but the cursor comes back here, right? So it looks for a bunch of numbers, and the cursor comes back here. Now we're looking for space, a bunch of space, and this doesn't satisfy it because it's just a bunch of numbers. So that's the thing you have to be careful of. So here we have a bunch of numbers followed by space. And actually, to further clarify my point, what I'm going to do is I'll actually just do this, which is put this in a non-captured group as well. All right, so if I run this as well, we get an empty pattern. Okay, so this doesn't mean consecutive. It doesn't mean one followed by the other. So let me just go back and explain this once more. Okay, I know I'm driving this over and over, but this is very crucial for you guys to understand. So after the space, we're looking for a bunch of numbers. It doesn't consume this, right? So it's not being consumed. So it's not like it looks for a bunch of numbers followed by a bunch of space followed by a bunch of letters. So this is not one followed by the other. It's actually all three at the same time, or it's looking for all three conditions. So these are actually three separate conditions. So what's actually happening here is it's looking for a bunch of numbers. Okay, that gets satisfied, but it's also looking for a bunch of space, which in this case is not being satisfied, and it's looking for a bunch of characters. So in this case, which is not being satisfied. So it looks and then it comes back. So this condition gets satisfied. So it looks, this condition gets satisfied. Okay, then it goes to the next condition. That doesn't get satisfied. So it comes back, and we get an empty pattern because this entire thing is the pattern. So we're looking for something that fits this entire pattern. So once again, this is the zero width assertion that it doesn't consume any characters. No characters are being consumed. It just looks, and the cursor sort of comes back. So once again, that's a key point, and that's why we're getting an empty string. Now, if we actually wanted to consume, remember, we wanted to consume the cherry, apple, grapes only if this portion gets satisfied, right? So what we can do is we can put this entire thing in look ahead. What it does is it looks for a bunch of characters followed by space, bunch of space, followed by number, space, and that. So a bunch of characters followed by space, followed by numbers, blah, blah, blah. This doesn't get consumed, so the cursor moves back here. And the only part that's getting consumed is, of course, this. This is our actual pattern. And since we're not using any groups, already defined all, we'll just pull out our entire pattern, which is cherry and apple. So cherry and apple satisfying this condition. So hopefully, yeah, you guys understand that. And let's just move ahead to the next portion. Okay, so I have one more example. And here, it's actually showing you an example of where lookarounds are very useful and how you can use lookarounds, consecutive lookarounds, the correct way to use consecutive lookarounds. Okay. All right, so this is our pattern. Now, this pattern looks pretty complicated, but all it's doing is looking for a bunch of characters. None of this is being consumed. It's all within this. It's looking for a bunch of characters followed by an A to Z, a lowercase letter. Then this is looking for a bunch of characters followed by an A to uppercase. This is looking for a bunch of characters followed by a digit. Essentially, what this is doing by using consecutive positive look aheads, what we're doing is we're making sure all four conditions have to be satisfied. This is very, very useful for password validation. So you know when you sign up for a website and they want to make sure that you're using at least one punctuation mark, one uppercase, and one letter. Well, I'm assuming they're probably using regular expression. They're probably using something like this to make sure you actually insert a capital letter, you actually insert a punctuation mark, you actually insert a lowercase letter, and number. So they're using regular expression to be successfully able to do that. Okay, so let's just check this out. So what this is essentially doing is we have to have at least one letter, one uppercase letter, one number, and one sort of punctuation mark that falls within this category. If all of those are satisfied, what we're going to do is we're going to consume the entire string. So this is where the consumption actually happens, and these are just checks. So these checks, they check the entire string, come back, check the entire string, come back, check the entire string, come back. And if all four are satisfied, then we want to consume the entire string because we know the password is valid. So if I run this, we have two different strings, string 1 and string 2. Now I'm going to run.
We understand what he means by consumed in the string. Just. But I think I'm gonna try to do this. Maybe I should write it down on the notes thing. So if I understand, I can put the three groups that I need here. AZ, AZ, 09. I don't think it's gonna work, but doesn't hurt to try, so. And it doesn't matter if I put two of them, but I think I'm gonna try with two, then if it doesn't work, I'm gonna use just the first two. And doesn't work. Interesting. This one adds space between all of them. I think we're just gonna look it up. Yeah, so using look aheads. I think this is a negative look ahead. Probably will watch these videos later to understand more. And he was talking about passwords validation. Makes a lot of sense. And it's probably something that is important to know, but I just suck at it. Regex. I hate it. Okay, nice. Let's see if all of them passes or. I don't think I'm gonna continue, even if they don't pass. Probably gonna take a break and continue this another time. Okay, nice. Yeah, but I'm happy with this. It's just the regex that I didn't know. Should probably practice more. Okay, so I think I'm gonna stop here. I'll probably continue this tomorrow. I think I'm gonna do these challenges here off stream, at least some of them on Cold Wars, and then I'm gonna continue doing these other challenges some other time, because I'm gonna take a break for now. So, and watch these videos here. So yeah, see you then.